Hey, it's Robert Naini, your spray foam advisor. In today's day and age, you have to be more than just a spray foam contractor. It's not enough just to be an insulation guy and be out there to sell insulation and provide insulation to the market. You are fundamentally changing the way building envelopes work. You have to know a little bit about that. That's why we talk so much about building science here at Spray Foam Advisor. It's important for you to know that when you do something to the building, like change the way that bulk liquid flows, change the way that air flows, change the way that heat flows, or even change the way that vapor flows, you are fundamentally changing the building physics and the dynamics of that structure. So when you look at a product like closed cell foam insulation, knowing that it can address all of those attributes, it can address bulk liquid, it can minimize address the flow of air, vapor, and thermal heat flow, you have to be aware of how that building is going to be affected when you use either open cell or closed cell foam in a structure. So to know that, we talk a little bit about building science, and one of the key concepts from building science is understanding flow, how things flow. And this is a basic physics concept. Things flow from high concentration to low concentration, high heat to low heat, high vapor to low vapor, high concentration of liquid to low concentration of liquid. This is just standard physics. All things flow from high to low. You even see this in nature when you see a group of people and they're trying to disperse. They flow from the high concentration of people to the low concentration of no people. This just happens as a natural occurrence. It happens with social situations. It happens in economics. It also happens in building science and building physics. So when you're aware of this, when you know that things flow from high to low, then you know that to address moisture flow, for example, or we'll talk about bulk liquid first, bulk liquid flow into a structure, you need to put a barrier in place that will retard that bulk liquid from going from high, generally the outside, to low, generally the inside of a building. How do we see this in construction applications? Well, typically we see it in the form of a drain plane on the exterior of the envelope. This could be a building wrap or some type of skin that's going to protect the wood on the exterior from getting wet. It's going to divert bulk liquid away. And for example, when we install closed cell foam on the outside of buildings, we're providing that bulk liquid drain plane with closed cell foam in that application. The next layer becomes the air barrier. We want to retard air. We want to minimize the amount of airflow from the exterior to the interior, from the high contamination of bad stuff to the low contamination of stuff. So air brings with it heat, air brings with it moisture. We want to minimize airflow from the outside to the inside, so we put an air barrier in the assembly. The next layer is going to be your thermal layer, your insulation layer. We put that in place to minimize heat flow, to create more efficient structures, to create have lower heat loads and lower impact on the building as a whole. That is the insulation layer, or your thermal boundary. And the fourth and final control layer is going to be your vapor control layer. Your vapor control layer is going to address moisture vapor in the air. It's going to help mitigate any moisture drive. It's going to help you try to control the combination of your insulation and your vapor control layer. Is going to help you control condensation points throughout the wall assembly and help you determine and calculate where that condensation point might occur. If it's going to occur in the wall assembly, you can identify where the dew point might be. But when these systems are constructed properly, we're able to create systems that just work, that flat out work long term, over time, and we have excellent structures because of that. Now, a good example is really probably the ultimate example in the spray foam industry is using closed cell foam, as I've mentioned, on the exterior of buildings. This creates that multiple application or multiple product use in one application, where we provide a drain plane, a vapor retarder, an insulation, and an air barrier all in a single application on the exterior of a structure. Protect that structure from the impact of the elements on the outside of the building. We overall create a better system and a more fundamentally operational system. It just is going to operate better over the long term by moving all of those control layers to the exterior of the structure, to the exterior of the building envelope. And then of course we can't forget a proper air management system. The HVAC contractor, the mechanical contractor, has to do his job properly and design a system for the building envelope that you've constructed. But your job is more than just insulation. You have to be a performance contractor. You have to be a thermal envelope contractor. You really have to be aware of the building science behind how what you're doing is going to change the structure so that you can educate your customers and ultimately work with that HVAC contractor, that mechanical contractor on the project so that this project works effectively and efficiently over time to get the best result for the end customer, because that's your goal. This is Robert Naini with Spray Foam Advisor. Thanks for watching. Check out some more videos.